So I hope I'm audible. We'll start with the session. So welcome to the 11th week on the course Integrated Waste Management for a Smart City. I'm Abhishek Raj, a PMRF scholar in the Department of Civil Engineering, IIT Madras. So firstly, the outline for this session. So we'll have an overview of the 11th week. So what was the content that was covered in this week, followed by the practice assignment, and then we can take on some doubts. So moving on to the overview for the 11th week. So the first lecture was C&D waste management. So how is the waste managed, construction and demolition waste. Then the procedure for beneficial use. So what are the criteria that needs to be checked before we judge the suitability of a waste, if we can get some beneficial or economical value out of it. Followed by this was lecture 2. So that was about the case study on the Hurricane Katrina. So it generated millions of tons of C&D waste. So how this waste was managed, what were the types of waste, what were the issues with it. So this was in lecture 2, followed by the disaster debris management in context of the Hurricane Katrina. Then we had the third lecture, lecture 3. So this was about electronic waste in categories. So what are the different types of e-waste that are possible? What is the categorization in terms of weight, in terms of components? So this was in lecture 3. And then we had the facts and figures pertaining to e-waste in the Indian context. So this was about state-wise figures. Which state produces the most waste, which state produces the least, what is the growth rate of e-waste in India. Then there was also some statistics on what is the percentage of waste that is recycled. And the next lecture we will see why do we need to recycle e-waste. So that was in lecture 4. So there will be different chemical elements, uh, rare earth metals in e-waste, so that can cause environmental and health hazards if not managed properly. So that is why there is a need of recycling, also due to the fact that they can cause hazard, and also because we can get some economic value out of these elements, because these are precious elements. So we can get some economic value. And moreover, if we use other waste management techniques such as say landfilling, so that can cause problems such as leaching of the harmful chemicals. Then there was lecture 5. So that was about e-waste management. So how e-waste is managed in the context of the different companies that are doing it. So these are basically the private operators that manage e-waste. They collect the e-waste from the end users and do the proper segregation, and then they try to get out beneficial benefits out of the e-waste in terms of economy and also in terms of recycling. So this was the overview for this week. So this week mostly we will have easy questions, so I hope the students will answer. So question 1, so this is about we need to fill in the blanks. So is an outcome of a product or a substance that is no longer suited for the intended use. So the given options are reuse, waste, disposal, and so can we have some response for this? Relatively easy question. Okay. So we have a response for B. So here we are talking about the outcome of a product or a substance that is no longer suited for the intended use. So whenever we buy a product, so here let's talk in the context of e-waste since this week was about it. So let's say we buy a mobile phone. So a mobile phone will have certain life depending upon how the person is using it. It may vary. So let's assume it to be around 3 years for now. So after 3 years, the person can shift to a new mobile phone, or let's say he may not even need a mobile phone, so he switches to some other device, a tablet maybe. So in these cases, so what happens is the old mobile phone has lost its intended use or economic value also we can say. So that has no use for the end user. So that case it is called as waste. So here we are talking in context of e-waste. So this can hold true for other scenarios as well. So if we order something on Amazon or Flipkart, so there will be a packaging associated with it. So once we open it, there is no use for the packaging, so that becomes waste. So it has lost its intended use. So we can call it as waste. That is option B. So reuse is nothing but a method of managing the waste. So we know all the three R's. So it is reuse, recycle, and reduce. So that disposal, it is the method when it is the final step in terms of waste management. So if we cannot do anything with the waste, we finally go for disposal. So it is usually done for normal waste. It is done in landfill. For CND waste also, there will be a designated landfill which will be specially for CND waste. For e-waste, we generally avoid to do landfilling. So this was question one. Option B is the correct answer. So option B, waste. Students can refer to the third lecture of this week. So here we can see the definition. It was, I think, the first slide. So waste is an outcome of product or a substance that is no longer suited for its intended use. So moving on to question number two. So this is a poll. So which state produces the lowest per capita e-waste in India according to the V assessment study 2005? So Andhra Pradesh, West Bengal, Delhi, and Bihar. So we have one response. So we have one response for D. Any other responses for this question? I'll wait for a minute since I think one student joined. So this is a poll, question number two. So which state produces the lowest per capita e-waste in India according to the V assessment study 2005? So we have one response in the chat and one response in the poll for option D. So I'll end the poll and discuss the answer for this. So which state produces the lowest per capita e-waste in India according to the V assessment study 2005? So what is per capita e-waste? It is the total quantity of waste that is generated divided by the population of the region. So whatever region we are considering. So here we are considering states of the India. So it will also be, so this is the mathematical definition, but this will be a, you can say, a function of the per capita income and other socio-economic characteristics of the area. So depending upon this, it changes. So what the study in 2005 found was for the state of Bihar, the e-waste was the least. So it may be due to several reasons. So it may be the reason may be that the per capita income of the state is lower. So the people don't use much electronics or appliances in the state. So it can lead to low per capita e-waste. And it can also be due to the fact that even if the total quantity of waste that is generated in Bihar or even in any other state is on par with any other state, but what happens is due to extra population, increased population of the state, so the per capita value goes down. So the total quantity may be the same, but population will be low. So Delhi may produce a certain quantity of waste, but the population of Delhi is around 1 crore. So compared to, if we compare it to any other state like Bihar, so it is around, I think, 12 crores. So even if they produce the same quantity of waste, so for Bihar, the per capita consumption or the per capita generation will always be lower. So that is one of the facts. Remember, so this was a study of 2005. So the figures may have changed. Moving on to the answer. So option D, Bihar, was the correct answer. You can refer to the third lecture of this week. So here we can see the growth rate of e-waste in India. Just change. So here we can see it is around 14.68 million tons, and it has grown up to around 185 million tons. So the figure is of 2005, and this is the projected figure for 2025. So it can be seen that it is around, it has become close to, if we take this as 15, so this has grown up to almost 12 times, we can say. So there has been a 12x growth in the e-waste generated in India. So over the past, you can say, 20 years. So when we talk about the highest per capita e-waste generating state, so that is Delhi, and lowest per capita e-waste generating state is Bihar. So for Delhi, there is another reason why Delhi produces a lot of e-waste, because Delhi also constitutes the NCR region. So NCR has the IT hubs in Gurugram and Faridabad, Ghaziabad, those places are there. So there are a lot of IT hubs. So consequently, the e-waste production of Delhi goes up, and also the per capita income of Delhi is higher. So all factors contribute to producing more waste per. So India is the fifth biggest producer of e-waste in the world. So discards around 1.7 million tons in 2014. So this is the second question. So moving on to question number 3. So this is the simple question. So we have to expand the term V. So WEEE. So waste electronic and electrical equipment, waste electrical and electronic equipment, and waste economical and electrical equipment, and waste electrical economical equipment. So we quickly have some response for this. Question 3. Okay, so B. Anyone else? Okay, no issues. We'll discuss that question. So this is the term given by EU. So this means waste electrical and electronic equipment. So the primary reasoning for this is the alphabetical order of the words. So here we can see the first six letters are the same, but here we have a I, but here we get a O. So I comes before O, so we put electrical before electronic. It is also a general convention to use electrical before electronic because for anything electronic to work, we need firstly electricity, and electricity is directly related to the word electrical. So that is one of the logics that is used for keeping electrical before electronic, and also alphabetical order is also there. So option B is the correct answer. So this refers to basically e-waste. So it is the expanded term for e-waste. So e-waste is simply we call it as electronic waste. So the scientific term for that is waste of electrical and electronic. Option B is the correct answer. So waste electrical and electronic equipment. You can refer to the third lecture of this week for this question. Moving on to question number 4. So solid waste produced during the construction, renovation or demolition of buildings, roads, bridges and other artificial structures is called construction waste, demolition waste, construction and demolition waste and municipal solid waste. Can we have some responses? Okay, let's see. So here we are referring to the solid waste which is produced during the construction, renovation or the demolition of buildings, roads, bridges and other artificial structures. So this is so the answer is in the question itself. So here we can see the word construction. Here we can see demolition. So we call it as CND waste or construction and demolition waste. So this may include number of things. So we can have say concrete because in demolition a lot of most of the amount we can say around 90% of the voluminous if we see that will be concrete. Then we can have bricks. Then we can have say old wood can be there. In foreign context there will be gypsum drywalls because they they don't use much of concrete and bricks, so wood and gypsum will be higher in case of the American or the European context. Then we can also have some paints, wires and other materials, so this will be much less proportion. So all these constitute CND waste. So it will also include the waste in debris. So in case of some natural calamity like earthquake or a flood, so what the waste is generated, so that is CND debris. So that is also included in this. So option C is the correct answer: construction and demolition waste. So option C, construction and demolition waste. You can refer to the first lecture of this week for this question. So moving on to the next question, question number 5. So this is a poll. So what was the number of electrical and electronic appliances that became e-waste in 2010? So the given options are 2 billion, 3 billion, 4 billion, and 5 billion. So this is a statistical question. Proper poll, you can answer it. And launch the poll. You can also answer it in the chat. Okay, we have one response for B. we have any other responses for question 5? Okay, so we have one response in the chat for option B, I think. Yeah, one response in the poll for option B. Let the poll now. We'll discuss the answer. So yeah, this is as per analysis, research analysis that was conducted. So it was done way back in, I think, 2012 or 2011. The report came out. It was based up to the data of 2010. So around 3 billion, it was estimated that electrical and electronic appliances had become waste in 2010. So option B is the correct answer. So this research was based on the sales data that was provided by the different companies, and also the data from different e-waste service providers that was used to come up at this figure. So this is an estimated figure. It may be maybe more, it may be less. So an estimate was that around 3 billion of appliances have become used in 2010. So depending upon how much devices are sold, we can estimate how much will go into the waste stream. So that is why sales data is used. These insights e-waste providers, service providers can also give us. So option B, 3 billion is the correct answer. You can refer to the third lecture of this week for this question. So here we can see some statistics. So 3 billion of electric and electronic appliances became waste in 2010. So globally about 20 to 50 million tons of e-waste are disposed, which accounts only 5%. So around 95% of the e-waste doesn't even come into the waste stream. So according to CAG report, over 7.2 million ton of industrial hazardous waste, 4 lakh tons of electronic waste, 1.5 million tons. So different types of wastes have been given in the country annually. So this is as per the CAG's report. So here you can see for e-waste it is 4 lakh tons estimate. But the growth is exponential in India. So we saw the graph that it has grown by almost 12 times in the past 20 years. Moving on to the next question. So question number 6. So which of the following disease is caused by exposure to beryllium? So given options are brain cancer, neurotoxicity, berylicosis, and cardiac arrest. So can we have some response for this? So I think we have a response. Okay. C. Yeah, so CAG report is published by the Auditor General. So I think it comes out biannually every 2 years. I think it comes out on different topics, not just waste. So for different topics, it comes out. Industrial growth, waste management. Even for defense, I think there is a CAG report. So there will be different reports in different areas that come out. So this was for solid waste management. So different types of waste, so they were estimated. The values were reported in the CAG report. So here coming back to this question. So for exposure to palladium, which disease occurs? So you can see in the it is quite obvious. So we have beryllium in the word here also. So berylicosis happens due to exposure to beryllium. So brain cancer can occur due to exposure from silver. Silver can cause brain cancer, excessive silver. Neurotoxicity we can have from lead. And cardiac arrest we can have from number of elements. But when we talk about exposure to beryllium specifically, so it causes berylliosis. That is option C. So option C, berylliosis. So it's week 11, lecture 4. So beryllium is usually used in these switchboards and printed circuit boards. So it offers high conductivity. So it is a carcinogenic. So it can cause cancer itself. And then we have chronic beryllium disease. So berylliosis, a disease which primarily affects the lungs. So exposure to beryllium can also cause skin diseases characterized by poor good behavior. Moving on to the next question, that is question 7. So this is a poll. So e-waste is segregated into which of the following categories? So options are printed circuit boards, electronic components, computer peripherals, and all of the above. So let's drop a poll. You can answer it in the chat also.
Hello, boss. We have one response for option D in the poll. The response is in the chat. Okay. We'll give maybe a few more seconds and we can discuss the answer for this. Okay, so no responses in the poll and one response in the chat. I'll end the poll. We'll discuss the answer. So e-waste is segregated into which of the following categories? So PCBs includes
the circuit boards which are used in mobile phones, computers, laptops. Nowadays also in fridge also there will be some certain circuitry which is used, which comprises of PCBs. So A can become e-waste. So then we have electronic components. So electronic components can have the above PCBs. It can have wires. It can have the frame, which is used for conduction. It can have certain plastics also, which are used for reducing the chances of a fire incident. So these are flame retardant. So BFRs. So the different kinds of things can be there in the electronic device. So that are called as electronic components. So option B is also correct. Then we have computer peripherals. So this can include devices such as mouse, keyboard, monitor, and so on. So C can also come into e-waste stream. So e-waste is segregated into each of these following categories. So the correct answer will be all of them. So option D, all of the above is the correct answer. You can refer to the last lecture of this week for this question. So at an organizational level, we segregate it into four categories. So it includes computer peripherals, PCBs, electronic components. There will be electrical wires, and there can be a others category. Moving on to question number 8. So which of the following is a major component present in the e-waste? Glass, plastic, metals, and liquids. We have some response for this.
Signal.
Okay. So yeah, metals is correct. So when we talk about e-waste, so major component will be the metals. So metals also there will be two types. So first will be the ferrous metals, that is iron-based metals, and then there can be non-ferrous metals such as aluminium. So these are used in e-waste. So primary objective of using metals is to provide it stability. So stability, or also we can say strength. So we don't want a very big sized object to be very light because it can cause stability issues. So it should have a certain inherent strength. So for that we use metals. Also, also in certain cases such as the coil in fridge, so that is used for increasing the conductivity and transferring the heat in the condenser. So that is the major component present in the event. So this is as per weight. Volume wise, it may not be the highest. Volume wise, maybe plastics are highest, but since plastics may not have much weight, so if we see about the weight, metals will contribute the most. This is also because of their high density. So even with low volumes, they can contribute more to the mass. So option C, metals is the correct answer. So nowadays, the newer emerging appliances, they use more of plastics, glass, and much less of metals. So option C, metals is the correct answer. So we can refer to the fifth lecture of this week. So here we can see the approximate distribution of e-waste. So glass is around 20%. So this is used in the screens. In plastic we have around 23%. So it is used in the body, in the framing. Metals we can have 57%. So this will include PCBs, cables. So cables also will have metal. So that will have basically copper. So copper is a non-ferrous metal. So that will also go into the metal category. Then we can have ferrous metal, which can include elements such as stainless steel. Non-ferrous metals we can have aluminum, copper, and there can be other elements also in e-waste, so which will come in non-ferrous metals such as cadmium, lithium, which will be there in batteries. So moving on to the next question, question number 9. So hydrometallurgical process technique is used for the processing of which type of waste? So construction debris, municipal solid waste, biomedical waste, and e-waste. And we have some response for this. Okay. So hydrometallurgy is a process of mineral extraction. So we will have a ore. So we'll use our leaching agent. In presence of, there can be certain catalysts. So there can be heat, there can be light, there can be some other chemicals as well. So in the presence of these, the leaching agent tries to leach out the metal from it, and the impurities will also be there, which will be separated using some physical or chemical process. So usually, like in hydrometallurgy, what happens is the impurities will form like a froth on the top of the liquid, and they can be removed from there. Since the metal is heavy, so that deposits into the bottom of the container or the unit. So metal will be obtained as a precipitate. So it is used for the processing of electronic waste. So we will not use it for municipal solid waste, so because it won't have much of metals. So here we are talking about a metallurgical process. So we need to extract certain metals. C&D debris can have multiple things. Concrete, wood. It is not ideal to be directly used for metallurgical process. Although we can use it for some kind of extraction of iron from the rebars. So this is also not correct. These also not correct. Biomedical waste we generally prefer incineration, so that we want to eliminate the chances of any kind of infection which can occur from biomedical waste. So C is also not correct. So e-waste can have a number of elements. So we can use hydrometallurgical processes. So it won't be from an individual device. So from thousands of lakhs of devices, we will have the circuit boards. We can use it to extract let's say the lithium from it. So option D is correct. So it will be done on a large scale so that we can obtain the rare earth metals which have been used to gain some economic value. Moving on to the answer for this, so option D, e-waste. You can refer to the fifth lecture of this week. So the technology being used for e-waste recycling is followed by pyrometallurgical. So pyrometallurgy is basically this is done in the presence of heat. So pyro means heat, and hydrometallurgy means there will be a aqueous medium, so which will act as the leaching agent. So these processes are combination of manual and mechanical processes, which manual processes form large part. So there will be different kinds of leachings in hydrometallurgy. So we will also see this in one of the questions ahead. So question number 10. So this is a poll. So what are the multiple pathways and receptors needed to be considered for determining the potential beneficial use of industrial waste? So direct human exposure, biodegradability, toxicity, and impact on the ecosystems. Can we have some response for this? Okay, so we have one response. So you can respond for this directly in the chat. So we have one response A and D. Wait for one more minute and we will discuss the answer for this.
Okay, no responses. Only one response we had. So
We should discuss the concept. So here we are talking about the multiple pathways and receptors that needed to be considered for determining potential beneficial use of industrial waste. So this is nothing but what are the criteria that we need to consider for determining if we can use any waste material for its beneficial use. So the first thing obviously that we need to check is what is the direct human exposure. So this is for the people who are engaged in the collection segregation of the waste, so they can get exposed to the harmful effects of this waste. So we need to consider that. So that is option A is correct. Biodegradability we are not worried about here, so this we will usually take care when we want to check for municipal solid waste for landfilling purpose. So how much time will it take to biodegrade? So B is not correct. Toxicity we should consider, but it kind of gets considered within the D itself, or you can say A itself. So it is not separately considered. So it is inherent in the option A and option D. So we need to consider the impact on ecosystem. This is how much leaching can happen, what effect can it have on any other animal or flora and fauna species. So that also we need to consider. Leaching into groundwater can happen. So we need to consider these factors. So A and D are correct. So option A, direct human exposure. Option D, impact on ecosystem. So this was part of the first lecture of this week. So before determining the potential of for beneficial use, we need to assess the risk to human health and the environment. So how do we judge the effect on human health? So that is through direct human exposure, and for environment we see the impact on ecosystems and also contamination of groundwater. Moving on to the next question, question number 11. The following are the different leaching methods for precious metals recovery using hydrometallurgical processing technique. So the given options are cyanide leaching, thiourea leaching, thiosulfate leaching, and shredding of e-waste. Can we have some response for this? A is not correct. No problem. Discuss the answer. So here we are talking about hydrometallurgical process. So what do we do in this? We use a aqueous medium for leaching the metal. So there will be a certain leaching involved. So depending upon what agent we are used to using to leach the metal, so there will be different types. So we can use some cyanide based element, thiourea or thiosulfate. So A, B, and C. All these three are different types of hydrometallurgical process. So shredding of e-waste is not a hydrometallurgical process. It's basically a physical process. It's not a. Moreover, we cannot obtain like directly precious metal recovery. So we shred for different purposes. So for TCLP test also we need to shred the e-waste into small components. So it is a physical process. Here we are concerned about a chemical process. So A, B, C are correct. Cyanide leaching, thiourea leaching, and thiosulfate leaching. This was part of the fifth lecture of this week. So I think we also discussed this in one of the previous questions. So for e-waste recycling, we use pyrometallurgical and hydrometallurgical processes. Hydrometallurgy contains cyanide leaching, halide leaching, thiourea is there, and thiosulfate leaching is there. So four techniques. So question number 12. So this is the poll. So which of the following statements are true? Landfilling of e-waste can lead to groundwater contamination. Human health is not affected by e-waste. Burning of cathode ray tube emits toxic fumes, and 10% of e-waste produced in India is recycled. So can we have quickly some responses for this in the chat? Okay, so A and C. I'll wait for one more minute if anyone else wants to respond. Okay, so I think we have only one person here now. So move on. So, which of the following statements are true? So, landfilling of e-waste can lead to groundwater contamination. So, yeah, this is correct. This is because e-waste contains certain metals which can leach into groundwater, thereby contaminating it. So, human health is not affected by e-waste. So, yeah, this is not correct because we saw the different types of diseases, environmental health hazards that can be caused by e-waste and the components present in it. So, human health is indeed affected. So, B is not correct. Then we have the burning of cathode ray tubes that emits toxic fumes. So cathode ray tubes contains lead, so to prevent the harmful rays from passing to the human eyes. So yeah, burning it will cause toxic fumes. So C is correct. And 10% of e-waste produced in India is recycled. So yeah, this is not correct. So as per the statistic in the lecture, so it is around 4%. So we recycle less than 5% of the e-waste that is produced in the country. So, option A, landfilling of e-waste can lead to groundwater contamination. This was correct. And option C, burning of cathode ray tube emits toxic fumes. So, you can refer to the fourth lecture of this week for this question. So, why do we need to recycle? This will contain the different facts. So, here we have the landfilling of e-wastes can lead to leaching of lead into groundwater. So, that can contaminate it. If we crush and burn a CRT cathode ray tube, so it can emit toxic fumes. There is huge impact of health and environment because of e-waste around, and also there is only 4% of the e-waste that is recycled. So all the facts that we saw in the options were in this slide. Moving on to the next question, question 13. So what are the different steps followed by a company in the management of e-waste recycling, collection, dismantle, treatment of waste, and recycling? So can we quickly have some responses for this? So A, B, and C. Okay. Okay, we'll discuss the answer for this now. Yeah, so we are talking about the steps that are followed by a company in the management of e-waste recycling. You should see that we are talking about recycling. So D will obviously be there. We'll recycle. So then, for before recycling, also we need to collect the e-waste. We need to dismantle it. We may also need to segregate different types of components. Then we need to recycle or send it to the treatment unit. So treatment, we are not worried about treatment here. So treatment will be done by the required authorities or service providers who do treatment. So we are here only concerned about recycling. So for doing recycling, we'll do collection, we'll do dismantling, and finally we'll move on to recycling. So these will be the different steps. So A, B, and D are correct. So option A, collection. Option B, dismantling. Option D, recycling. So you can refer to the last lecture of this week. So firstly, we'll collect. After collecting, we'll transport. Then we will segregate the different components. Then we can do dismantling, and finally we will move on to recycling. So we have totally 5 steps that are used in recycling by the companies. Moving on to the last question. So question 14. So this is a poll. So Itai disease is caused by the presence of selenium in e-waste. So true or false? Can we have some response for this? Okay. Okay. So yeah, it is not caused by selenium. It is caused by the presence of cadmium as far as so mark false. So here we can see so false was the correct answer. So it is not caused by selenium. You can refer to the fourth lecture of this week. So here we can see cadmium. So it is a carcinogen. Long-term exposure causes Itai disease, which causes severe pain in the joints and spines. So it is a bone-based disease. It affects the kidneys and also softens the bones. So this was the last question for today's class. If you have any doubts, you can ask. Else, please feel free to log out. Okay, PBT is yeah. First of all. So yeah, PBD is basically it's a component. So it will also be found in e-waste. So I think it is polybrominated diphenyl ethers. So that is PBD. So I think it has cancerous effects. So it has been found to cause tumors. So any other doubts? You don't have any other doubts? We'll close in 1 minute. Time. Yeah, so milled asphalt pavement is yeah. So basically, we will have the pavement bituminous road, that is the black topping road that we see. So once it becomes old and we need to make a new road due to the damage or whatever be the reason. So for making it, what we do is there will be there are I think ACE is there, JCB is there, certain companies are there which make a machine. So that what it can do is it basically grinds the pavement. So the pavement material will get grinded out, and then it also mixes fresh bitumen into it. So it uses the same bitumen of the road and mixes fresh bitumen with it to add the strength, and then it again lays over the pavement. That is called as milling. So it is called as milled asphalt. Any other doubts?
So yeah, that is a category of
C and D waste for asbestos. And friable is also there. You can refer to the slides for it. It will have more details. That was covered last week. So basically, what it means is that there will be first category will be friable. So that will have around 1% of asbestos. So asbestos, some anything is not pure asbestos, so it will have certain component of asbestos. So asbestos sheets also. There will be concrete mixed with asbestos. So up to 1% we call it friable ACM. So asbestos concrete material or something like that. So friable ACM is up to 1% and beyond 1%, so it is non-friable. So friable means it can be degraded with hand pressure also. More than that, the strength goes high, so it is non-friable. So we need equipment and apparatus for that. That's how we classify it. Friable, non-friable ACM. Okay, so we'll close the session now. Thank you for attending the session and see you next week.